So this is Monday, January 8th. Integrating e to the x and a to the x. Okay, consider antiderivative of e to the x dx. Do you know what function's derivative is e to the x? This is our favorite one. So, who has a derivative of e to the x? E to the x. So that means that let's just say it this way, the derivative of e to the x is e to the x. So that means the antiderivative of e to the x is e to the x, although not quite, plus c. This will require some u substitution, but this will be another one where, well, let's fill in the boxes. So e to the x plus c. The antiderivative of e to the u du would be e to the u plus c. And this is one of those days where like every problem is going to end up like that. The key thing will be u substitution again. And kind of like last time, if after you get the hang of some of these, you probably won't write out the u substitution. You'll figure out how to do it. Others of you will write it out every time. That's all right as well. All right, so number one, the antiderivative of e to the x is e to the x. No adjustments needed on that one. But number two, there's a 2 in there, so maybe you could figure out like how to undo the chain rule, but first time through, let's just let u be 2x. That way we'll have e to the u, and that we know how to handle. Du is 2 dx, so I can spawn a 2 into the integrand as long as I also put a 1/2 out front. So now I've got 1/2 antiderivative of e to the u du. Again, every single problem today, you're eventually going to get antiderivative of e to the u du. It's all about the u substitution to get there. So 1/2 e to the 2x plus c. And if we think about checking that by taking its derivative, the derivative would be e to the 2x times 2 for the chain rule, and the 2 times 1/2 would cancel each other out. So that, again, the u substitution helps us undo the chain rule. Number 3, gosh, I feel like it's an awful lot like number 2. Any guesses on what number 3 will be without me having to do the u substitution? 1/3 e to the 3x plus c. Because the 1/3 will cancel the chain rule 3 that shows up. How about number 4? Hearing no takers, we'll do u substitution. Maybe we should slow it down. So du is 1/2 dx. So I need a 1/2 in there with the dx, which means I need a 2 out front. So 2 antiderivative e to the u du, 2 e to the 1/2 x plus c. And again, if you think about the chain rule, when you take the derivative, chain rule would give us a 1/2, which would cancel out the 2 that's there. How about number 5? What do you think u should be for number 5? Again, the goal on all of these is get e to the u in there. So what should u be for this guy? 1 minus 3x, that would be nice. So du would be negative 3 dx. So negative 3 and negative 1/3. Negative 1/3 e to the 1 minus 3x plus c. Pretty much u is going to always be the exponent of e. Except that number 6 looks weird. What could I do with 1 over e to the x? What algebra thing could I do? Let's make it e to the negative x. And then now it looks like we want it to look. Let u be the exponent. Du is negative dx. So throw a negative in there with dx to make it work, but then a negative out front to cancel the negative that you just added. And again, every single time we're going to get down to antiderivative of e to the u du. Negative e to the negative x plus c. And I guess multiple choice, they might try to get fancy and flip that upside down again. Negative exponent. Number 7. Thoughts on number 7? On what u should be? This is where knowing your derivatives is helpful, and knowing them well. Well, our usual rule is let u be the exponent. I'm going to rewrite that as x to the negative 2, because I can take a derivative of that a whole lot easier than 1 over x squared. So negative 2 x to the negative 3. And that doesn't match exactly, but it kind of does, because that would be negative 2 over x cubed dx. And so that we got that if we put a negative 2 in there. And then a negative 1/2 out front. And then all of this stuff is du. So once again, antiderivative of e to the u is e to the u. So e to the x to the negative 2 plus c. Again, or they might write that as e to the 1 over x squared plus c. Thoughts on what we do on number 8? What's that? Let's divide. Like, we can simplify that thing first. Before I let u be 2x or x or the numerator or the denominator, let's divide them each by e to the x. I'll even slow it down. All right, I can divide each of them by e to the x. These are algebra questions, so let's pick on some people here. Gregory, I think you get the hardest one. I think Mia gets the easiest one. And Addie gets kind of the middle one. So I'm not asking for an antiderivative. I'm just asking for the algebra. Gregory, what's e to the 2x divided by e to the x? Let's back up. How do you do How do you do x to the 5th divided by x squared?
X to the 3rd.
And what did you do to get that? Okay, so use that same rule. E to the x. Mia, what's 2 e to the x divided by e to the x? Good. 2. And Addie, there's nothing really to simplify, but how might I rewrite 1 over e to the x? Good. E to the negative x dx. Okay, that was algebra. Now we do some calculus. I can definitely call on people for the first two, I think. And then feeling confident that Quinn could handle the last one. So, Rabia, what's the antiderivative of e to the x? E to the x. Lauren, what's the antiderivative of 2?
I don't know.
2x. Had me worried there. Quinn?
Negative e to the x.
Very nice. Wait, what'd you say? Negative e
To the negative.
to the negative x. And then plus c. So algebra first, and then it wasn't too bad after that. With that algebra step. Alright, that was all our e to the x problems. Let's add an extra line up here to the top of this page. I mean, we said this already, but just to remind ourselves, the derivative of e to the x is e to the x. But what's the derivative of 5 to the x? Do you remember? There's like an extra piece tagged onto the end of that. Well, the first part is, it's similar to this. The derivative of 5 to the x is 5 to the x. But there's kind of a chain rule thing. We multiply by been too long. Natural log of 5. That's one we don't use often. So let's just say generically, what's the derivative of a to the x? A to the x times natural log of a. Okay, so if we take a derivative, we multiply by natural log of a. What do you think happens if we take an antiderivative? Still going to be 5 to the x, but to undo the multiplication, we will divide. Division is the opposite of multiplication, the inverse of multiplication, and so the opposite of antiderivative is derivative, so instead of multiplying by natural log of 5, we'll divide by natural log of 5 plus c. Same thing on the others. Antiderivative of 7 to the x is 7 to the x, but divide by natural log 7. Antiderivative of 3 to the x. Grenier's not here, but that was an easy one. I think. Monty, follow the pattern here. What's the antiderivative of 3 to the x? Yes. Plus c. I forgot the plus c, but you remembered. Thank you. And so the antiderivative of a to the x is a to the x divided by natural log of a plus c. And with u's, it's kind of the same thing. A to the u divided by natural log of a plus c. Again, there will be lots more u substitution to be had. Well, I say that, and then number 1, Ian, I bet you can answer number 1. Ian Jewell, sorry.
That would be 2x times ln2.
I like the plus c. But what did you say before then?
ln2.
In the top or in the bottom?
Oh,
In the bottom. You take a derivative, you multiply by it. You take an antiderivative, you anti-multiply. Right? If you're taking an underderivative, then you unmultiply, which would be dividing. All right, number 2 isn't quite so clear. But Bryce, based on all the other u subs we've done today, what do you think for a u?
4x.
Let's do 4x. So du is 4 dx. So we spawn a 4 and a 1/4. So 1/4 antiderivative 9 to the u du. So I got a 1/4. Antiderivative of 9 to the u is 9 to the u, but I need to divide by natural log of 9 plus c. I don't know that we've talked about this in here, but that actually is a safe stop. Since you've defined what u is, you can leave it like this. I think previously I've said you couldn't leave it like this, but I went back and checked, and since you've defined what u is, you can do this. Now, multiple choice, I'm probably going to clean that up a little bit. 9 to the 4x over 4 natural log 9. All right, just go ahead and combine the denominators. Number 3. Leo, what do you think for u? 3x squared. Good. Ian, you were so eager to grab that other one. We'll get you in here. What's the derivative of 3x squared?
6x dx.
Very nice. 6x dx. So we're close. Kylie, what do I need to do to my integrand to make this work?
Multiply by 1/6 on the outside.
Okay. Multiply by 1/6 on the outside because we're gonna have a 6 on the inside. So 1/6 antiderivative, and then all of that stuff is du, and the exponent was u. And so, as always with u substitution, you take something that looks terrible and you get it to something that looks easier, right? Maybe not easy, but simpler. Antiderivative of 2 to the u would be 2 to the u over natural log 2. Don't forget there's still a 6 in the bottom. And a plus c. And that is a safe stop as long as you've defined u. Like, hey, don't forget, there's my u. You don't have to do that, but if you wanted to sort of clarify. Multiple choice, they would go ahead and fill that back in. And just to be not silly, but kind of silly, and to remind you of a property of logs, would you believe that that's the same thing? Bryce's like, nope, wouldn't believe it. Where did the 64 come from?
6, so 2 to 6.
Right, if you could put the 6 as an exponent. You would not choose to do that. I would not choose to do this. Like, why is someone doing that? I don't know, but on a multiple choice test, sometimes they do silly things to make sure that you're okay with the algebra. Right? I don't like that because like that's not even a calculus idea. But occasionally they'll do stuff like that, and you're sort of stuck here thinking, how did they get 64? Well, they use that log function. All right, last one, and then we'll look at the worksheet. I kind of don't like number 4. Brandon, any thoughts what we do first with number 4? Good. Let's make it 5 to the negative 2x. And my guess is some of you would probably would do this one without writing out the u substitution, or at least sort of just do it in your head. But probably most of you aren't there yet. So u is negative 2x. du is negative 2 dx. So a negative 2 and a negative 1/2. And so we end up with a coefficient out front of negative 1/2. 5 to the, I'm going to go ahead and substitute it back in on the fly here. 5 to the negative 2x over natural log 2. And once again, you could get creative with that too and put it as the exponent and have natural log 4 down there. Nobody would do that on their own. It's just multiple choice people might do that to see if you're, I guess, paying attention. All right, so today's assignment, let me leave off worksheet 4. And while the video is rolling, I'll remind you that due Wednesday is worksheet 1 through 4. So in theory, 1 through 3 are already done. Maybe, hopefully, in theory. And then that gives you 2 nights to do worksheet 4, and then we'll turn them in on Wednesday. Thank you, Bryce. I'll hit record because that's not right. What's it supposed to be? Natural log 5. I don't know where the 2 came from, other than right there, I guess. But yeah, that should be natural log 5. Good catch. What would you do on 10? If you glossed over 10, what would you do first on 10? We've done it a couple times. We did it once earlier today even. Algebra first. So I would make this 5e to the negative 2x minus e to the negative x, and then I'm ready to go. Alright, but yeah, number 11. Thoughts on what u should be so that du might show up? It's actually kind of similar to one we did from last worksheet at the very beginning of class. Ideas on what u should be so that du shows up. This is where you got to know your derivative rules so that you recognize what's going on. What's the derivative of natural log of x? 1 over x. So we got that. That's du right there. Natural log was u, so this looked like a u, or I mean a natural log problem, but really it's just a power rule problem. Although, good question on number 11, because I need to change those. I've got to change my limits to be u limits. Right now they're x limits. If x equals e cubed, the natural log of e cubed, you know what the natural log of e cubed is? Speaking of properties of logs, bring the 3 down front. What's the natural log of e? 1. So my upper limit after all that work is just 3. Alright, for my lower limit, if x is 1, then u is the natural log of 1. We said that earlier today as well. What's the natural log of 1? E to what power would give me 1, right? I'm thinking the fishhook thing. E to what power would give me 1? 0. So my bottom limit went from x equals 1 to u equals 0. And after all that work, I think all the natural logs and e's are gone from this problem, because the antiderivative of u squared would be u cubed over 3 from 0 to 3. So 3 cubed over 3 minus 0 cubed over 3. How's that for a safe stop to leave? Obviously, there's a lot more that could be done with that. 27 divided by 3 is 9. So reduces to 9, but hey, if you're just working without multiple choice answers, right? Once you get to a good stop, be done with it. We get into some kind of mixed review here, like number 12. I don't want to work the whole thing, but what do you think u should be? 3x plus 1. Du then is 3dx. So get the 5 out of there. So 5/3 antiderivative. I'm not putting 0 and 4 on there because that's x stuff, and I'm in the process of making this a u problem. Du over u. What's this going to be? What's the antiderivative of du over u? Natural log of u. Don't do that yet, though, because you need to change those upper and lower limits. All right, why don't you see if you can finish that problem? So change the limits, take the antiderivative, and then plug in top minus plug in bottom. And the potential error from here is to plug that x stuff back in for u. Why would that be a problem? Do you know? The limits, right? I got my limits switched to u, so I can't go put the x stuff back in unless I want to revert back to x limits. So that's another way to do it. You can put the x stuff back in, but then you got to go back to the x limits. So always be careful that everything's in u or everything's in x. When you start switching back and forth, people forget to switch one or the other, and they don't switch everything. So 5/3 natural log of 13 minus natural log of 1, and that's a perfectly good safe stop. That won't be the multiple choice answer. Why won't that be a multiple choice answer? What's an easy simplify there? Natural log of 1 is 0, so 5/3 natural log 13. Again, wouldn't be wrong, but it probably would not be there as an answer choice on a multiple choice test. Okay, the main thing on this one is this was not a, well, 11 wasn't either. These weren't e to the u problems. These were throwback problems. So we start to kind of shuffle the deck on you here, so that it's not, everything today is all this type of problem. It's like, we start to mix it up on you. All right, again, worksheet 1 through 4 due on Wednesday. Tomorrow is fairly easy. Tomorrow is not the next page in the worksheet packet, by the way. Since we have an extra day, we're going to do a trig review. So if you remember your unit circle, tomorrow should be easy. If you don't remember your unit circle, well, then figure it out by tomorrow.